If you want to define a building structurally, then there are three ways. Either the building can be a load-bearing structure, or the building can be a frame structure, or the building can be a combination of both. That is a load-bearing structure as well as a frame structure. So these are the three types a building can be structurally classified or defined, where load-bearing system or load-bearing structure is a thing of past, frame structure is the present and the future, and composite structure is making the use of best things of the two world, that is load-bearing and frame structure. Now let's first of all see what a load-bearing structure is. See, if you want to highlight some points regarding load-bearing structure, then the first thing can be stated is it consists of slab, beam and load-bearing wall. This is the important term, load-bearing wall. Here you will not see column word. This term is absent from load-bearing structure. The system consists of slab, beam and load-bearing wall. Now, how the load transmission is there? It is from slab or roof or ceiling, then through wall and finally to the strata where the structure has been constructed, where the structure has been built. There is limitation in the number of floors that you can have in a load-bearing structure. The load-bearing structure is restricted only up to 3 floors. You can have only 3 floors when you are going for load-bearing structure, which is in contradiction with frame structure, where you can have n number of floors in frame structure that we are going to discuss in further slide. Then the strata, the foundation requirement for load-bearing structure is that it requires a hard strata as foundation. Another disadvantage regarding load-bearing structure is that the total carpet area provided by a load-bearing structure for the same given plot size is very less, because most of the portion of the building is covered by the thick walls. And now the final thing, where load-bearing structure is preferred, where we should go for load-bearing structure. It is suitable for small residential 1-room, 2-room units. Okay. Now let's see what a load-bearing structure looks like. As you can see in the diagram, a roof truss is there, that is ceiling or roofing structure is there, and the roofing system is kept on load-bearing brick wall. And the load-bearing brick wall is continuing to the foundation, where the expanded area can be seen as the footing, and concrete bed is provided which is supporting the footing. And this whole structure, this whole thing is placed on a strong hard strata. Okay. Then how load transmission is taking place? Whatever the load which is being exerted by the structure is taken to the strata by the load-bearing walls to the soil, and the soil in return provides reaction. This is how simplistic way, this is a simplistic explanation, this is a simplistic logic how load-bearing structure is transferring its load from the structure to the soil below. No complexity is here. When we are talking about frame structure, the load transmission flowchart is kind of longer, is kind of complex, where we say that load gets transferred from first slab, then to beam, then to column, then to footing, then to strata. Okay. In case of a load-bearing structure, the logic of load transmission is very simple. Whatever the load of the structure is there, it is taken by the load-bearing wall and it is then transmitted to the soil below. Alright. Now we will see how frame structure is different than the load-bearing structure. We will see some highlighted points regarding a frame structure. See, the highlights regarding frame structure are, it is nothing but a system of slab resting over beams supported by column. Okay, focus here. It is a system of slab resting over beams supported by columns, and the column go way down below where footing is there, and the footing or the foundation transfers all the load of the skeleton to the strata below. Okay. Second point, load transmission from slab or roof or ceiling is from minor or cross beams, then to major beams, then to column, and finally to footing. That is finally to footing and then to hard strata. Now the good point regarding frame structure is there is no restriction of floor. The skeleton is made up of reinforced cement concrete, which is very strong, which is very much able to carry all the load from the number of floors that you are going to have in a frame structure. Then another added advantage is that since there are no thick walls, the walls are thin and they act as a partition, they act as a division wall only. That's why more carpet area, more usable surface area is available to the end user, that is to the consumer, when he is having a frame structure as his residence or the place of utility. Okay, now we will see how a frame structure looks typically in a diagram. See, as you can see in the diagram, roof slab is there, then floor slabs are there, then floor beams, column and plinth beam and footing. All this skeleton is seen. All this skeleton can be seen in the diagram where no partition wall or no importance is given to wall. Now recall this thing, in a load bearing structure, no importance was given to the term column. There was no element as column in the load bearing structure, but here column is there and no importance is being given to walls or partition wall, because partition wall do not make up as a skeleton member, as an important member, as a functioning member in the frame structure. In frame structure, partition wall are only there to make up the available space, to make up the area, to define the space, to define that specific area. Okay, these are the advantages of having a frame structure, and this is how typically a frame structure looks in a diagram. Then we are now focusing how a frame structure is transferring its load to the soil below. See, the flow chart is very simple. Okay, it is first slab, then minor beams, then major beam. Here in the diagram, here in the flow chart, we have mentioned only beam, but first from slab to minor beam or cross beam, then to major beam, then to column, then to footing, and then to ultimately strata. Okay, this is how frame structures load transfer take place. So with this said, now we will move on to next thing, which is a composite structure. Okay, composite structure is nothing but combination of both these things. That is, it will be picking advantages from the load bearing structure, which is thick wall, which can also act as external protective wall to the whole structure. Then in order to have more area, more ceiling area, we can incorporate the advantages of a frame structure. Okay, now we will see in detail how a composite structure is there. See, in a composite structure, we say that it is a combination of frame and load bearing structure. Then external walls are made as load bearing walls. Then intermediate supports are made as RCC column. See, external walls acting as a load bearing wall is a derivation from load bearing structure, and the RCC columns is a derivation from frame structure. Okay, means we are utilizing the things from load bearing as well as frame structure. Then composite structure support a very large span of roof, and that's the reason industrial building make use of composite structure. The external thick load bearing walls support the end support of the roof truss, and intermediately, whenever intermediate supports are required to protect or to support or to hold up the ceiling or the slab or the roof or the roof truss, RCC thin columns are there, and having thin RCC column in intermediate manner make up a large space over there. It is the saving of space inside the structure, inside the composite structure. Then where it is suitable, where we are going to use a composite structure, it is suitable for sheds, then warehouses, then factories, whatever industrial buildings are there that require external wall as protective wall or as end support for their roof truss, and inside they require large space availability is required at that specific building. That's why these kind of composite structures are suitable for sheds, warehouses, factories, in short, industrial building. Now we will see how a composite typical structure looks like. See, as you can see in the diagram, load bearing walls are making up as the external wall, and they are acting as the end support for the roof truss, and the intermediate roof truss supports are provided by thin RCC column, which are effective in taking high load, but they are thin in cross section, less in cross section. That's why they consume very less space. Okay. So with this said, we have seen what a load bearing structure is, what a frame structure is, and what a composite structure is. Okay. So I will see you in the next video. Till then, take care. Bye bye. Do follow us on Telegram, Instagram, also on Spotify. I also upload audio podcast on Spotify.